Okay, first two questions are quite elementary, just some confidence builder. Let's try them. 3x minus 6, 3 times 2 is 6. 9, distribute the minus sign. So you have, you can subtract x both sides to get rid of this, and then add 6 both sides. You have 3x minus x, which is 2x. 9 plus 6 is 15 minus 21. That's what you get. What's 15 minus 21? Negative 6. Okay. Yeah, you should be able to do this mental math. When you're subtracting something larger from smaller, try to think of it as negative of the larger minus the small one. Yeah. So instead of doing 15 minus 21, think of 21 minus 15, which is 6, and you just put a minus sign. Okay, that way you see that 2x is equal to negative 6, and then if you divide both sides by 2, what's the answer? Divide both sides by 2, you get negative 3 as the answer. Okay. Okay, this second one is slightly more challenging because now you have decimals. It's not much though. It's almost the same. You just have to add 0.3x both sides to cancel the 0.3x on the right. Subtract 3. And what's 0.2 plus 0.3? 2 plus 3 is 5, so 0.5x is what you have on the left side. What's 8 minus 3? That's 5. And then, what is it? 5 divided by 0.5, right? Okay, how do you calculate 5 divided by 0.5? Yeah? Yeah, you multiply top and bottom by 10 so that you get 50 divided by 5, which is 10. Okay, what's the idea of solving such a thing? Yeah?
Get rid of the denominator by
Yes, yeah. Because we don't like denominators. We don't like fractions. So we multiply something, both sides, to get rid of the denominator. And to do that, you have to think about the least common multiple of 3, 4, and 6. What's the smallest number that's divisible by 3, 4, and 6? 12, right? So what you want to do is you multiply by 12. And then 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 6 is 2. And that gives you 4 times 2x minus 3. 2 times 3x minus 7. Beautiful, right? You don't have any fractions. Now let's continue. 4 times 2 is 8x minus 3. And then 2 times 3x is 6x. 2 times 7 is 14. So that's what you get. Subtract 6x, both sides. Add 3, both sides. So that on the left side you get 2x. On the right side you get 3 minus 14. What is 3 minus 14? As I said before, instead of doing 3 minus 14, you want to do 14 minus 3 and put a minus. So what's that? That's negative 11. And finally, dividing both sides by 2, you get negative 11 over 2. Okay, now these questions are about solving for an indicated variable. We have to solve for a. And for these questions, I tried to explain it by using this metaphor of socks and shoes, where when you put it on, you put socks first and then shoes, but when you take it off, you take off the shoes first and the socks. So when you undo something, you do it the opposite order of what it was done, right? So if you look at this, here you're trying to solve for A, therefore you want to see what's being done to A. What's being done to A first? You're adding a B, and then multiplying by 1/2, and then multiplying by H to give you this A, right? So if you want to get rid of things on this right side, what must go away first? What was the last thing that we talked about on the right side? Multiplication by H, right? So that has to go away first. Let's divide both sides by H. So this H now gets divided by H. After division by H is gone. Now what should go away next? 1/2, okay? Now to get rid of 1/2, one might suggest, oh, divide by 1/2, which is not incorrect. You could do it that way. But division by 1/2 is a bit complicated because you're dividing by a fraction. Well, you have to eventually use that division by a fraction is the multiplication by its reciprocal. But the faster way to do things when you have a fraction like 1 over something is just to cancel it by multiplying the denominator both sides, just like how we did some other questions. Okay, so multiply by 2 both sides. We'll cancel this denominator, and you end up with 2 times A over H equals to this part. Okay, let me simplify this a little bit. When you multiply a number to a fraction, where does it get multiplied? Do you multiply both top and bottom? Yes? No. You only multiply to top, right? Why is that? Well, because 2 is equal to 2 over 1. Right? If you multiply fractions, it's top to top, bottom to bottom, so 2 times A over 1 times H. That's what you're writing. And therefore, you get 2A over H as the left side if you simplify. And then finally, what must be removed on the right side? Obviously, plus B, right? Just subtract B, you have 2A over H minus B equals to A as the answer. Now this is fine as an answer, but probably a better way to write it as is to have A on the left side. I don't care, either will be given full credit, but I think more people will be happier when you write it this way. Okay, so that's that. Now let's look at the second question. This is a bit different. Can you see why? You're trying to solve for H, but where do you see the H's? I see an H here, I see an H there. Uh-oh, that's not good, because the way we were doing things was identify what was being done to something and you're trying to undo it, but I can't undo two things at the same time. So before you even try to solve for H, you have a separate task to do. You have to make these two different H's to be just one H. So what's the idea? How do you rewrite the right side so that H appears only once? Is there an idea? How would you do it? Think about, yes?
You divide like the L and W out?
No. Yeah? No. Well, the idea is to factor out H.
You divide on both sides.
No, that's not what I'm trying to say. What you want to do is you want to factor out. That's the verb. Okay, factor out H. In other words, I see that this has H, that has H, and you can factor the H out. Okay. Now, if I factor out H from these two terms, what's left from here? 2W. How about here? Nope. H is taken out. 2L. Okay. And beautiful. Now you only see one H. We had two before, which was a problem. now you only see h. Okay, good. And if you see it this way, then now the order of operations is clear. So to h, this is being multiplied, right? And then you're adding 2LW. You see the order, right? So h times this is done first, and then you're adding this. So what must be done with on the right side? What should be done away with on the right side? Which one did we do later? We multiply first and then added, right? So what should go away first? Huh? What? Yeah, the addition should go away first. So it's 2LW should go away first, okay? So you subtract 2LW equals to 2W plus 2LH, just like that. And now once you're done with that, you have to get rid of the entire 2W plus 2L by dividing by 2W plus 2L. The entire 2W, 2L plus 2L should be done away with. Okay. So that these two cancel away, and now you have H. Let's write down as H equals to S minus 2LW over 2W plus 2L. While it's very tempting to see if you can get rid of this 2's by canceling, unfortunately, because this doesn't have a 2, there's no way to cancel these 2's. Okay? Yeah, there's no rule that says you can cancel one of the 2's here. If these two are multiplied, then yes, you can cancel the 2. But if these are added, you can't cancel this 2 with the 2. So there's no more simplification you can do. Therefore, this is the answer. The question says to solve these and write the answer in interval notation and also graph it on the number line. So after we finish solving it, we have to figure out what it looks like on the number line, and using that, we have to write down the interval notation. Okay, first, add 9 both sides, divide by 2, and then you can add 1, right? But then 1 is 2 over 2, so you can rewrite the right side as 9 over 2 plus 2 over 2. What's that? 9 plus 2, that's 11 over 2, right? So you end up with the solution x less or equal to 11 over 2. Sometimes these linear inequalities are quite straightforward, just like solving a regular linear equation. The only thing that you have to watch out for is that sometimes this direction of the inequality has to be flipped. When do you do that?
You divide by negative.
When you divide by a negative or multiply by a negative. Whenever that happens, you have to flip this, right? But here we're dividing by a positive, so there's no need to flip. Okay, so that's the answer. Now let's try to draw the graph. I mean, sometimes some teachers might ask you to write 0, 1, 2 for the number line, but we're not going to go. We'll just try to draw it very schematically and not draw all these numbers. 11 over 2 is 5.5, so right before and after there will be 5 and 6, but we don't care. We'll just put some mark here and say this is 11 over 2. Now, because x is less or equal to 11 over 2, the solutions are things that happened before 11 over 2, including 11 over 2, because it has a bar here. This means less or equal. So equal is okay, right? And that's why you put it as a solid circle. Now, if this was a strict inequality, you would put a circle with empty inside, right? But this includes 11 over 2, so that's the proper way to graph it. And how do you express this in interval notation? Where does this interval begin? Negative infinity, right? It starts at negative infinity, and it stops at 11 over 2. You still have to figure out if this is like a round one or a square one. For negative infinity or infinity, it's always the round one. But for regular numbers, you have to determine whether it's this or this. And it's determined by whether it includes 11 over 2. If this is a solid circle, then you use the square one. If this is an open circle, where the inside is empty, then you use this round thing, okay? So in interval notation, that's the answer. Okay, now let's solve this inequality with the absolute value sign. So 2, absolute value x minus 1. You want to add 9 to both sides. The solution is very similar to what we did over there, right? So, and in the beginning, it's very similar. Okay? So you divide by 2. Now, sometimes it's tempting to multiply this 2 to inside the absolute value. Usually not a good idea. Don't do that. Right now, it is possible you could multiply by 2, but then, when there's a minus in front, then you're not supposed to. So because there are some cases where it could be leading to some very wrong notations, it's better not to move anything from outside the absolute value to inside. Okay, so never do that. Just get rid of 2 by dividing by 2. So you have an absolute value less than 9 over 2. And that's when you actually need to think about this separately from there, because these are very different now. Okay? Before, we didn't have an absolute value. Now we have an absolute value, right? So how should we do this? Any suggestions? Yes?
It'd be negative, the range is negative 9 over 2 to 9 over 2.
Yeah, so when you have an absolute value less than a number, then that thing would be between the negative of this number to positive of this number. So let me write this down as a rule. So if you ever have something like absolute value less than some number, then the solution would be that whatever that's inside the absolute value must be between the positive a and negative a. Now, I'm only writing down strictly less because the original was strictly less. If the original one had equal sign, then the other ones should also have equal sign, depending on whether you have it or not. Okay? So if you don't see a strict inequality, if it has an equal sign in there, then you put it. If this thing doesn't exist, then you only do strict. Okay? So that's the general rule, and that's what I'm applying here. Something absolute value is less than some number, therefore it's in between. Now, whenever I tell you something in general, there's a danger of just accepting it because your math professor said it, so it must be true. The better thing to do is to actually think about some simple example to see why this is true. So let's spend some time thinking why such a thing is true. So I'm going to do something very, let me not even put an X there. I'll just put a question mark. Very simple, like 2. What question mark could satisfy this inequality? Can you give me some examples? 2. Okay, what else? Negative 2, because negative 2 absolute value is 2. What else? 1, 0. -1, right? Does 3 work? No. Does -3 work? No, because -3 absolute value is above 2, right? So after doing some example, you see that, oh yeah, -2 does work, -1 does work, 0 works, 1 and 2 works, and everything in between, say -1.5, 0.5, 1.7, all of these numbers in between from here to there should satisfy this, right? That's why your conclusion is that, oh, this number must be between plus and minus of this number on the right side. Okay? Now, what if the right side is a negative number? What satisfies this? Can't do it because absolute value always produces a positive number, so no number satisfies this. Okay? So there's another thing that I forgot to write over here is that A has to be non-negative. If A is negative, then you don't even go that far and just say no solution. Okay, so once you know the general idea and you've investigated it through some simple example and you accept that that is indeed true, then you can apply it into this situation and say, hey, something absolute value is less than a number, so that something must be between the plus and the minus of that number. That's what I write. Okay, but we're not done yet. We have to solve for x. How do we solve it? We add 1 everywhere. And when you add 1, think of 1 as 2 over 2 so that it's easier to calculate with the fractions. So that makes x to be between 9 over 2 plus 2 over 2 is 11 over 2, right? What's 2 minus 9? -7. So the 2 minus 9, think of it as 9 minus 2 and then put a minus sign. So it's -7 over 2. And x is between -7 over 2 to 11 over 2. Okay? All right. We still have to draw the graph for this. The graph is, here's -7 over 2. Here's 11 over 2. And x is a value between those two things, right? Everything in between. Is -7 over 2 itself included? No, because it's a strict inequality. In that case, what kind of circle do I put here? You put an open circle. So there's nothing filled in. Same deal. 11 over 2 is not included, so you put an open circle. In terms of an interval, where does this interval begin? At -7 over 2. Where does it end? 11 over 2. Are the endpoints included? None of them are. So what do you use? Curved brackets, right? The open brackets. So these are the extra answers that the question was asking. Okay, next question. Very similar to the previous one. The only catch is now it's greater or equal. Let's see how that changes things. You have 1/2 absolute value of 5x minus 4 greater or equal to 3. Multiply by 2 both sides. And now what? What should you do? Well, I think what's needed is another general principle of what happens when something is greater than a number. So let's think about this other one. If something is greater than a number, and it could also be greater or equal, so in such a case, what's the general principle? Well, this time, rather than me telling you the general principle, let's see if you can figure this out. Suppose you have x, absolute value greater or equal to 2. What are the solutions? Give me solutions of this. What could x be? 2. I like question mark better. So this question mark could be 2. What else? Give me another number. 3, and then everything after, right? 2, 3, 4, 5, everything after. But there's other kinds of solutions that's not one of these. Give me another example. There are some negative solutions, right? What are the negative solutions? Negative 2. Absolute value of negative 2 is positive 2, so it does satisfy this. And then negative 3 as well, because negative 3 absolute value gives you positive 2. So you get, so the solution of this is like this. You have 2 and also negative 2, and you have everything before negative 2 and everything after 2. That's the solution. Okay? So in other words, if you have an inequality that looks like something absolute value is greater than a number, then you have two kinds of solutions. Either this could be 2 or greater, or, and that's the important word here, or it could be negative 2 or greater. Okay, it doesn't have to be. See over here, this is x has to be less than 11 over 2, and x has to be negative 7 over 2. There's an and that's hiding in this answer. Okay, in this answer, it's really saying that this question mark has to be both under a but over negative a. Okay, both conditions have to be satisfied. But over here, only one of the conditions have to be satisfied. Because you can't satisfy both. Can a number be both bigger than 2 and less than negative 2? No, can't happen, right? So when you write the answer for this one, you have to use this word or, okay, explicitly, right? Okay. So after thinking about this, we're ready to write down the general principle here. The general principle is that if the absolute value is greater than some number, then we know that it's either question mark greater or equal to a, greater, or question mark less than negative a. And let me put the equal sign a different color so that if the original question has equal sign, then the answer should also have that as well. Okay. All right. So we're going to use that general principle, especially this with the word or. Make sure that you use that or. So we have 5x minus 4 greater or equals to 6, okay? Or 5x minus 4 less or equals to negative 6. Okay? Either one of them has to be satisfied. Okay, let's add 4 both sides. You get 5x greater or equals to 10. Divide by 5, so x is greater or equal to 10 over 5. What's 10 over 5? That's 2. So we have x greater or equal to 2 as the answer for the first part. Or is the important word. Don't forget that one. 5x, well, if you add, oh, sorry, I should really write here. If you add 4 both sides, you get 5x less or equals to negative 6 plus 4 is negative of 6 minus 4. 6 minus 4 is 2, so you have negative 2 after adding these two. And then you divide by 5, what do you get? X less or equals to negative 2 over 5. Okay, so that's the answer. How do we sketch that on the number line? Let's try that. Here's 2. Here's negative 2 over 5. And the answer says either it's greater or equal to 2. So it's 2 and greater. Or negative 2 over 5 and less. These are the solutions. How do you write them as interval notation then? Well, we have 2 intervals, 2 pieces here. The first piece begins where? Where does this one begin? Negative infinity. Where does it stop? Negative 2 over 5. Okay, for negative infinity, what do I use? Round or square one? Always round one for infinity or negative infinity. Okay, how about negative 2 over 5? Round or square? The square one, because negative 2 over 5 is included, right? Okay, here it begins at 2, it goes till infinity, round for infinity, and 2 is included, so you use square and you put the union. So that's the answer in terms of interval notation. Set 9, you're given a bunch of quadratic equations, and you're asked to solve it using completing the square. And the question explicitly says that you have to use completing the square or else you don't get any credit. Okay, so how do we complete the square? Well, usually we put the constant term to the other side, but it's already over there, so we don't have to worry about that. And it's really the matter of putting some number so that the left side becomes a square, right? So we're trying to complete this left side so that it becomes a square, right? And the idea is to look at the first two terms and say, hey, usually, you know, if you have a minus b squared, what's the formula? You square the first, and negative b squared would positive be squared, because negative, when you square it, becomes positive. But there's something in the middle. What is this in the middle? If you do a minus b squared, what do you get in the middle? Not ab, it's negative 2ab. Yes, negative 2ab. That's what you get. So I keep saying double the product. This thing happens in the middle, double the product. I say it's double the product because a times negative b is negative ab. That's the product, right? Product means multiplication. So you have negative ab, and this 2 means you're doubling it, okay? So you think of this one, and see, if I have x minus 2 squared, then definitely x squared will happen here, and then negative 2 squared will give you something here, but then when you double the product of these two is what? 2 times x, and you double it, it's 4x, right? 2x times 2 is 4x. So this is going to produce this in the middle. X squared will produce this one. So we know that if it does get completed to a square, it must be x minus 2 squared. Okay, now the question is, what should the constant term be? What should the constant term be? Yeah? Yeah, it'll be positive 4 because you have negative 2 squared. That should be positive 4. And because we know that positive 4 completes the left side as a square, you should also add 4 both sides. Okay, so I kind of gave you a long reason why plus 4 should be added. But sadly, I realized after giving the first quiz, a lot of you couldn't really follow that logic. So let me just give you an algorithm that should just work for this exam. But it's usually not a good idea. If you have full understanding of what's going on, you don't need to memorize any algorithm. But since so many of you can't do it, let me just give you an algorithm to memorize for now. So the algorithm is take the coefficient of x take half, square it, and add to both sides. Okay, so that's the algorithm. Let me try to explain how this algorithm applies here. Okay, so what it says is take the coefficient of x. What's that? -4. What's the half of -4? Taking half means you multiply by 1/2, right? So 1/2 times 4, what's that? 2. So you get -2, square -2, what do you get? +4, right? So you get +4. So because you have -4 divided by 2, which gives you -2, and then you square this, you get +4. Now you know that +4 should be what's added both sides. Once you figure out that +4 is what you should add, then the left side will naturally become a square. Look, what are two numbers that multiply to 4 and add to -4? -2 and -2. So this factors as x minus 2 times x minus 2, which means it's x minus 2 squared equals to 5. Okay? So for today, I'll try to repeatedly use this algorithm. Hopefully you don't have to. You already understand why, clearly just by knowing the double the product thing. But you know, if you have to rely on this algorithm, promise me that you're going to take some time to actually figure out the logic, okay? All right, so you have this. Now you take the square root. So what is x minus 2 equal to? X minus 2 is equal to plus or minus square root of 5, right? And then you add 2, so x is equal to 2 plus or minus square root of 5. That's the answer. Okay, so we're done with that one. Let's try to do the second question. What's the first step? Yep. Subtract the 1, yes. So 1 goes to the other side as -1. Again, the same story. You take -3, take half, meaning you divide it by 2. Yeah, taking half means either multiply by 1/2, same thing as dividing by 2. Once you divide by 2, what do? What does it say? What does it say? Yeah, square, right? And then what do you get? 9/4. So 9/4 is what you add both sides. Okay, that's the algorithm. Okay, then this will become something squared. What would it be? X minus 3/2 squared. Okay? And if you're in doubt, you can take some time to FOIL this out. You write this as x minus 3/2 times x minus 3/2. First, outer, inner, last, you FOIL it out, and you'll see that it's exactly this. Another way to do it will be x squared will give you that. -3/2 squared will give you 9/4. And then what do you get if you double the product? If you multiply these two, you get -3/2x. But if you double it, the 2 in the denominator gets canceled, right? So you get exactly this. Okay? So keep checking, and at some point it will click. At some point it will be obvious why this becomes this. Right? Okay, on the right side, -1 should look like -4/4, so you can easily add. What is -4/4 plus 9/4? 5/4, right? And then you take the square root, which is x minus 3/2 equals to plus or minus square root of 5 over square root of 4. What's square root of 4? 2. So x minus 3/2 equals to plus or minus square root of 5/2. And this has to be added both sides, which gives you x equals to 3/2 plus minus square root of 5/2. Now, I'm fine with this answer, but seeing that they both have 2, I guess it's better if you write it as 3 plus minus square root of 5/2. That's a better way to write down this one. This is simpler. Okay, this next question is pretty similar, but there's a slight difference. There's a 2 in front of x squared. So what should you do? Divide everything by 2. Before even doing anything here, you should divide everything by 2, so it's x squared plus 4x plus 3 over 2. Okay, and once you have it that form, move the 3 over 2 to the other side and then do exactly what we did before. Okay, add all the terms by 2. That's because the way we understand the completed square only works when the coefficient of x squared is 1. Okay, so we have to divide by 2, and then you have x squared plus 4x plus 3 over 2 equals to 0. Now, subtract the 3 over 2 to the other side, right? And then we're going to apply the algorithm, which is to take the middle number, divide it by 2. What's that? 2, right? You square that, what do you get? 4. So you're going to add the 4 both sides. You add the 4 here and there. Now on the left side, if you factor this by looking at two numbers that multiply to 4 and add up to 4, that's 2 and 2, right? 2 times 2 is 4, and 2 plus 2 is 4. So this is going to, the left side can be factored as x plus 2 times x plus 2, which is same thing as x plus 2 squared. On the right side, 4 is what? 8 over 2, right? So the right side is 5 over 2. X plus 2 squared equals to 5 over 2. Therefore, x plus 2 is plus minus square root of 5 over square root of 2. And finally, subtract 2 both sides, and you get x equals to negative 2 plus or minus square root of 5 over 2. Now, I'm going to grade this as full credit, but to really get the correct answer, you need to rationalize the denominator by multiplying by square root of 2 top and bottom, okay? So if you do multiply square root of 2 top and bottom, you get negative 2 plus or minus. Square root of 5 times square root of 2 is 5 times 2, which is square root of 10. And then square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So that's a better answer. Okay, same idea. You want to divide everything by 3 so that you get x squared minus 2/3 x minus 1 equals to 0. Move the 1 to the other side, so you get x squared minus 2/3 x equals to 1. And now we apply the algorithm, which says take the middle number, which is negative 2/3. Now, what is half of 2/3? If you multiply by 1/2, what do you get? 2 and 2 cancels, right? What's that? You get negative 1/3, right? And you take that negative 1/3, you square that. That's what the algorithm says, right? Take half and square it. What do you get if you square it?
Over 9.
1 over 9. So what should I be adding both sides? 1 over 9. That's what you add both sides. Okay, let's continue. Now this thing is going to be square of what? X minus half of this, which is, we got it here, negative 1/3, right? X minus third squared. And whenever in doubt, just make sure that you verify that indeed this is same as this. You can verify it by calculating, right? X squared gives you this. Negative 1/3 squared is positive 1/9, which gives you this. And what is this middle thing again? How do you get the middle thing? You have to use the words that I use. Double what? Double the product, okay? Let's repeat. Double the product, okay? So you multiply these to 1/3 x with the minus, And if you double it, what do you get? You get negative 2/3 x, right? So that's why this gets created. Okay. So please don't forget double the product in the middle. Okay. Yeah. Okay. So you get double the product, creating this. So we know that these two are the same. On the right side, 1 is 9/9, right? So if you do 1/9, that's 10/9. So you have x minus 1/3 squared equals to 10/9. Now take the square root both sides, which gives you plus or minus square root of 10 over square root of 9. What's square root of 9? 3. So you have x equals to 1/3 plus minus square root of 10 over 3. Therefore, x is equal to 1 plus minus square root of 10 over 3. These are questions about factoring using AC method. So you remember what AC method is? What do we do first? Multiply A and the C, right? When you have A, B, C, you multiply A and C. That's why it's called AC method. So 2 times 5 gives you 10. And then you bring this negative 7 down here to create an X chart. And with the X chart, what you're doing is you're looking for two numbers whose product gives you 10 and whose addition gives you negative 7. Okay? What are those two numbers? Negative 5, negative 2. So you put negative 5, negative 2. Therefore, using these negative 5 and negative 2, you break up the middle one as negative 7x is negative 5x minus 2x plus 5 equals to 0. What you can do is you can take the first two and take the second two and factor separately. What's the common factor between 2x squared and 5x? X. So if you factor the x out, what's left? 2x minus 5. Okay. Over here, there aren't any common factors, but anytime you have a minus in front, you also have to factor the minus out. So you need minus of 2x minus 5. Now notice that I had to put negative 5 because negative of negative 5 gives you plus 5. Okay? So don't make this mistake. If you pull a negative out, you have to say negative of negative is positive. So you have this. Now that you have you have factored by grouping, if you did this correctly, you'll see that same parts appear in both of the groups. I see that 2x minus 5 appears in both groups. So you can factor out the 2x minus 5. And that leaves you with x from the first group. And there's an invisible 1 there. So it's minus 1 from the second group. So that's what you get. Now, when you solve x minus 1 times 2x minus 5 equals to 0, you have to use the zero factor property, which means the factor separately has to be 0. At least one of these has to be 0. So you solve this equals to 0, this equals to 0 separately. So by adding 1 both sides, you get x equals to 1 from the first equation. This one, you have to add 5 both sides, and then you divide by 2, you get x equals to 5 over 2. So that's your answer. For the second question, you have to first move the 12 to the left side. And again, you have to do the AC method. What is 6 times 12? Does anyone know? 6 times 12 is? 72. Good. So you get negative 72 as A times C. And then the middle number is 1, so you put 1 here. Now you have the X chart. Now you want to know two numbers that multiply to negative 72 and add to 1. What are those two numbers? Yes? No, if you add 72 and negative 1, you don't get 1. Yeah. 9 and 8, right? Yeah. Now, the problem here is that 72 has many factors. 72 could be 2 times 36 or 3 times 24 or even 4 times 18. There are many ways to think about 72 as product of two things. So it's a bit overwhelming, but notice this. If the product is negative, then one is plus and the other is minus. And if they're being added and you get 1, that means the plus 1 is only 1 more than the negative 1. Okay, so you're looking at two numbers that are very close by, creating the product 72. And what can it be? 9 times 8 is 72. Those two are very close. So that's like one way to think about it. You can kind of have your judgment to say, okay, this is really subtraction of two numbers because one is negative. And that means that since they only have to differ by 1, it must be this one. Okay. All right. So you have this, and then you are going to break up the middle just like before. 6x squared plus 9x minus 8x minus 12 equals to 0. Factor the first two, which is 3x, 2x plus 3. Now, if this is not so clear to you, make sure that you multiply it to see that it recreates what you began with. 3x times 2x does give you 6x squared. 3x times 3 does give you 9x. So always try to check by being able to go back. Okay? How about this one? 8 and 12 has a common factor of 4, so you can factor a negative 4 out. And again, negative 4 times 2x gives you negative 8x. Negative 4 times what gives you negative 12? Plus 3. And therefore, you see 2x plus 3 appearing in both cases, which means you can factor that one out. If you factor out the 2x plus 3, what's left? 3x minus 4 equal to 0. Same idea. You set 3x minus 4 equals to 0, so that 3x is equals to 4. Divide by 3, you get 4 over 3. Over here, 2x plus 3 equals to 0. Subtract 3 both sides. Divide by 2, you get negative 3 over 2. So these are the solutions.